Okay, so we ended the last video with looking at the typical method for solving exponential equations. This is on the bottom of page 4. This is where we ended class on Tuesday and kind of where we picked up for class on Thursday. All right, so I was kind of previewing that there's a property of logarithms that'll allow us to take the exponent, that x that was right there, and to bring it down in front, which takes the variable out of the exponent and puts it on the same line as everything else, which turns this equation right here into really a linear equation. You got to get to where, when you see this right here, that it doesn't look scary, because I want you to remember that this is just a number, okay, and that this is just a number. Now, it's not, listen to me, it's not good practice to do the log of 2 and say, okay, well, that's 0.301 with the x, okay, and then take the log of 50 and say, okay, that's 1.699 if I round to 3 decimal places. It's not really a good thing to do, especially those of you planning to do something scientific or to become engineers, because you rounded, and then your next step would be to divide by 0.301 on both sides. Oops, 301. Okay, so when you do that and you take 1.699 and you divide that by 0.301, we've kept enough digits of accuracy that it should turn out to be the same. But like when I did that, if I round to 3, I'm going to get 5.645 here, right? So don't actually do this. Don't really do the plugging in of the number. But I just want you to get to where when you see that, you realize this is a linear equation right here. It's some number times x equals a number. Okay, so that's the magic of this property of logarithms. It's called the third property of logarithms, and that's what's going on page 5, of the worksheet. Now, I didn't do page 5 next in class on Thursday. I went right towards solving, but I'm going to go ahead and do page 5. I didn't talk about this on Thursday, but I just wanted to go ahead and keep these videos in order. All right, so what these properties are, they're normally called property 1, 2, and 3. They're properties of logarithms. And what they allow us to do is to expand and contract expressions involving logs. This property is the one that we already previewed on the last page. We're going to use this all the time. Okay, this is like the one that said if you had something like log of 2 to the x, like that it would be okay to bring the variable down in front. Okay, that's what that property says. Okay, and rewrite it as x times log of 2. And the base on this, the a that you see in that formula, in this case was an understood base 10. But that's property 3 of logarithms. We use that one a lot. These other two allow us to expand and contract logarithmic expressions. And this is something that is sometimes useful when you are solving certain equations. It's also useful in calculus when you're trying to do a derivative of something. All right, so let's look at property 1. Property 1 and 2, they kind of go together. All right, property 1 just says if you have the log of a product, it says that the log to any base of a product equals the sum of the logs. Okay, so it's multiplication on that side, inside there, okay? But that multiplication can switch over here to be addition. Okay. So when you're doing the log of a product, it turns into a sum of the logs of the two numbers. And then see, a similar thing happens here. This is really division, isn't it? That's division. So if you have division, okay, here, if you have division there, it's going to become, so division here corresponds to subtraction on that side. So the log of a quotient, that's division. Okay, so log of a product is the sum of the logs. The log of a quotient equals what you would expect, because math is all about patterns, the difference of the logs. Okay. All right, now there's some logic to this. You know, exponents are logs. Should write it the other way around. We usually use it the other way around. Logs, okay. Logs really are exponents. So these properties of logarithms are actually connected to exponent properties. So you know how if you had x to the second times x to the third, how that becomes 2 plus 3, addition, and how if you had x to the fifth divided by x to the second, the shortcut was that you could subtract exponents. So the multiplying became addition in your shortcut. The dividing became subtraction. That's an easy way to remember this because logs really are exponents. Okay. All right, so what's happening on questions questions 1 and 2 is you're either expanding, stretching out the expression as much as possible, which you need a lot in calculus, or you're trying to contracting, trying to get them together into one log, which is what we really need a lot of for the stuff we're going to be doing, okay? And so if you're trying to expand this expression out, what we're going to do first probably is look at how that's multiplication, m to the fourth times n. So we could write that as log, still base 2. So the log of a product becomes the sum of the logs of those two items. That's property, that right there, that was property 1. Okay. And then our next step is to take the exponent and bring it down in front, giving us 4 times the log base 2 of m, and then we have log base 2 of n there. Okay, that's considered the final answer, fully expanded as much as you can. Okay. All right, we can do a similar thing here. We're going to expand it out. We have division. So that means when we start off, we're going to take the log of this quotient and we're going to separate it into the log base 5 of the square root of x minus log base 5 of 25y. Okay. And then this is kind of hard if you don't remember that a radical is really just a fractional exponent. So you really have log base 5 of x to the 1/2 there. Okay. Now here I see a product. Do you see that? So that means I can spread that out a little bit more, but this minus sign is going to get you in trouble if you're not careful. When you expand this out more, you're going to have log base 5 of 25 plus log base 5 of y. But there's a minus sign in front of all of that, okay? So in a moment, we're going to take that minus 1 really, that minus 1 that we have really right there, and we're going to distribute it, and that's going to give us a negative here ultimately, okay? So there's a couple things we're going to do to finish this up. One of them is to bring that 1/2 exponent out in front. Okay, that step here, we did it. That's property 3 that allows you to drag that exponent down in front. We're going to do that here. Get a 1/2 times the log base 5 of x. We're going to distribute the negative throughout, negative 1 throughout. So that's log base 5 of 25, and then negative times a positive is a negative log base 5 of y. Okay. Now you might get to where, and you might want to, just go right to separating it like that. See how both the 25 and the y are in the denominator? So they both should have a minus in front of them because they were both in the denominator. All right. Now there is one more thing we can do, because this log base 5 of 25, if you think about what that means, log base 5 of 25 has to equal something. This is unfamiliar to us, so let's flip it into exponential form. That's the base, that's the exponent, and that's going to equal 25. And so now by inspection, we can tell that's 2. So we're going to put a 2 right there. Okay. Not a whole lot more you can do, though. This will be minus 2 minus log base 5 of y. So this one is expanding an expression that involves logs as much as you can. And you do need that, but you need it more in a calculus class, I think. All right, but the second problem, that one we're going to need when we start solving equations on the next couple of pages. Okay, see, what we need is, since all of these are the same base log, we're going to try to contract this so we only have one log, okay, of something, okay? And here's what I want you to think. This is a good way to do it. See how you have positive and a negative? Okay, so you're going to wind up putting the x plus 2 on top, okay? And then you have plus this, so your plus will turn into multiplication here. So you'll have x plus 2 times x. See, this was positive out in front, this was positive out in front. So the x plus 2 times x is appropriate. But then you see how now we have a minus right here? So that means that 2 is going to be in the denominator. And you could leave it like that, but you'd probably see it written with the x first, like that. It's not more correct, it just looks better. And it would also be okay, you just don't have to distribute. But don't forget to keep that log base 3 on it. This is the best looking answer, but they're all correct, really. But that's a good way to do it instead of doing it in pieces. If you have a plus, it's multiplication, right? If you have a minus, it's division. All right, now this one's got a little added number out in front of the log. And so, you know, property 3 that allowed you to, let's go back one. You know, property 3 allowed you to bring the exponents down. We're just reversing that. In fact, that's what number 2 is doing in general. Expanding is this way. Contracting is that way. Okay, so that's what we're doing. We're reversing what we did on the first question. So we're going to bring that back up. So it's like we're rewinding. That's going to come up here and become a squared. And I don't know why, but textbooks typically leave off these parentheses, you know, but you really need them in your mind because I want you realizing that's function notation. ln of x is this 2 times the ln of x is the same as ln of x squared. Bring the 3 back up. Okay. All right, and then notice it was minus. So when you contract it and you bring it together, see what's happening is you're on the right side over here. And you're trying to contract it and get to the left side. So your subtraction becomes division. Okay, now be careful when you do that. When you do that and you contract it, it's one log. It's not ln x squared divided by ln y to the third. That's not correct. One log when you contract it. All right, so that's expanding and contracting. We're going to be needing this when we start solving equations. And then you need the other stuff kind of in later classes where you're taking derivatives. Okay, I'm going to stop this and then we'll get to the meat of the whole entire unit. I hope you guys are doing okay with this.